In this section, we're going to talk about Docker. Now, Docker is a very important tool when it comes to software development in the industry. And in this entire section, we're going to talk about what is Docker. In fact, we'll start with why in this world we need Docker and what are the solutions we have. Then we'll move towards doing the setup. How do you run a particular container? How do you build a Spring Boot application which you can run on a Docker container? And also we'll focus on multi-containers. What if you want to use multiple containers? And for that, we are going to use Docker Compose. And in this series, we're going to talk about all these things. So make sure when you're learning, also practice the things which I'm doing, because when you do it parallelly, you will learn more. Just watching the video, sometimes it will not make sense. So I hope you will enjoy the entire section and see you there. So before we talk about what is Docker, it is important to understand what problem we are trying to solve here. Now, as a software developer, what is your job? Our job here is to build application which millions of people are going to use, and then they can use it from anywhere. And nowadays, we make sure that you are building the web applications which are deployed on the cloud so that others can use it. Now, question is how you do it. Now, first of all, you write the code, and then you make sure that you connect with database, and then you also test your project. You do a lot of configuration, and then you are done, right? Now, everything what you're doing now, you are doing on your own machine, and then it's working fine. And sometimes when it works, you feel very happy. And that point, let's say if you're working with your team, of course, you have to give your project to your team. Now, what may go wrong there? The thing is, when you give your project to your team, they need to do all the things. Now, when I say all the things, what exactly I mean? I'm not saying they have to write the entire code by themselves now, because you have written the code, but the configuration. Let's say if you want to make a web application, for that you need a server, a web server. So when you started working on your project, you have installed a web server. But what about database? So let's say if you're using MySQL or Postgres or MongoDB, you will be installing this software in your machine. And not just this, there are multiple configuration involved here. So what you do is, when you started working on a project, of course, you will not complete the entire project in a week or a day. So it will take some time, right? Now, after doing all the hard work, now when you're giving this project to your colleague or maybe for testing, they have to do all this setup. And if one of the configuration is not matching, your project will not work, and they will complain, hey, the project which you have worked on is not working. And then you will say, it works on my machine. I mean, that's a common phrase which we use, right? So basically, we have to make sure that when you are making a project which is working on your machine, should also work on their machine, okay? Now, maybe your colleagues or your friends will understand this, but what about the testing team? So normally in the companies, we have different teams for it, right? So we have a development team, testing team, ops team. So when you give this project for your testing team to test it, even they need to have the same configuration. So they have to install all the softwares, they have to do the setup, they will do the configuration as well. And if something is not working, again, they will blame you by saying, hey, it's not working on my machine. Now, even if you do all the configuration correctly, it might not work. Because it depends upon your underlying OS and hardware. Sometimes the features which you have used might not work on their OS. Maybe you're using Windows, they're using Mac or Linux. It might not work. And then that's only testing phase, right? What about production? So let's say testing team was able to solve all the problem by talking to you, and now you're giving this project to the ops team. Now it is the responsibility of the ops team to deploy the project. Now they also need all the setup, all the configuration. I mean, they will do all this work. Additionally, when you talk about developers' machine, we are using a standalone laptops or normal desktops, right? But in production, you use heavy softwares or heavy servers, and they have different OS. It may happen that the project which you have built is not matching with their configuration. And again, there will be a thing like, okay, so you have given them the project on Friday, and they will call you on Saturday to get this resolved. Okay, not a happy scenario, right? So how do we solve this problem? So the problem here is, we want to make sure that when you build a project, you just don't give the project, because they have to do all the setup. Of course, with the project, you will also give a guide, the manual, what are the softwares needed, what are the configuration. But then what if you can give them the working project? Of course, you are giving them the working project, but then you're not giving the setup. Now, how do you give the setup? Maybe you can just simply copy your C drive, right? So imagine this, you are not just giving them the setup. You are saying, okay, I have a C drive with me. I will just give you this C drive and your problem will be solved. So what they will do is they will use your C drive and they will start working, because in your C drive, okay, when I say C drive, I'm talking about Windows, where you have your OS in the C drive. It changes depending upon the people, but let's go for general scenario. Now, there are multiple problems with this. First of all, if you give your C drive, what you will have. Second, can you really copy C drive if you want to do that? Of course, you cannot do that, right? You cannot simply copy an OS from one system and give it to someone else. It will not work. So what are the other solutions we have? In fact, there's one more problem. What if they have a different OS altogether, which will not support your system or your hard drive which you're giving? A lot of problems, right? So, and people used to do this, okay? So way back, people used to work in this fashion. They used to build a project and give the project to the testing team or the ops team, where they will do all the setup, all the configuration, and hell lot of process. Now we have to find a solution. Now what is a solution here? Now before Docker, of course, we are learning Docker here, right? But before Docker solved this problem, but then we'll talk about Docker later. But before Docker, we had one more solution which is called virtualization. So one solution is virtualization for our previous problem. So the problem is when you build a software or the application which works on your machine, it may not work on someone else's machine. Is because even if they do the configuration, which consumes a lot of time in terms of installation, configuration, even if you do that, it might not work. And to solve that problem, we are saying, okay, we can use something called virtualization. Now, before we understand how we can solve the problem with virtualization, let's understand what is virtualization. So what happens is, when you talk about your system, so let's say any system in which you work, even your mobile phone or your desktop, laptop, servers, they all do the same thing. What you have is you have a basic hardware. Okay, so you have a hardware layer. Now this is your actual hardware, your CPU, RAM, motherboard, all those stuff. Now on top of this hardware, to make it work, of course, as a user, will not be interacting with the hardware directly. What you need in between is OS. Now this is your operating system, which can be Windows, Linux, Mac, doesn't matter. There are multiple OS options available. So if you want to use your hardware, the only way you can do that is with the help of operating systems. And that's why when you buy a laptop, you get two things, not one. You're not just buying a laptop, you're buying Windows with it. Yeah, they say they give it for free, but you do pay for it. Okay, keeping that aside, you got a hardware and you got an OS. Now, in real world, we directly don't use OS, right? We use software. For example, if you want to add two numbers, you can't simply ask your OS to add two numbers. You need a calculator. Now you might be saying, hey, calculator you will find in every device. Not exactly. I don't know if you have used iPad. We don't have calculator there. Anyway, but you can install it. The point is, if you want to perform any operation, you need an application or a software. And as a user, you use software. Software talks to OS, OS talks to hardware. That's how the flow is. Now let's say as a developer, how will you use virtualization? So what you do is, if you want to use virtualization, you will be installing another OS. Okay, now that's tricky. How will you install two OS on the same machine? I mean, of course, we can do dual boot, where you have two OS in the same system, but at one time, you can use only one. Something like if you have a laptop, you can install Windows or you can use Ubuntu. You can install both as a dual setup or dual OS, but then you can use only one at a time. In virtualization, you use two OS at the same time. What we do is we have a hardware and then we install a OS. Now this is your host OS, the main OS. Now on top of it, you can install one more OS, but then how it exactly it will work? Because if you want to install, let's say we have a hardware, you have a Windows on top of it, and now you want to use Ubuntu. Now, when you try to install Ubuntu on Windows, Windows will say, what you doing? You can't install OS on OS. So Ubuntu says, even if you install me, you need a hardware. So what you do is you fake it. You say, okay, what if you can fool Ubuntu by saying, let me give you something in between, which is not a hardware, but it will behave like a hardware. Now that is your virtual hardware, or we can say virtual machine. So you have a hardware, on top of that, you got a OS, on top of that, you got a machine, which is not a physical machine, but a virtual machine, which is actually a software, which fakes like it's a hardware. And then on top of that, you can install Ubuntu. Now this is called virtualization, where you are installing an OS on a virtual hardware or a virtual machine. And this concept is very famous, okay? So if you talk about virtual machine, it's very famous, but question is why? Now think about this. If you go back to our previous example of a previous problem of Docker, not Docker, but application. When you build application on your machine, which is there in your C drive, let's say, or maybe on your OS, it's working on your machine is because you have the required software like a web server, database, configuration, network components, everything there configured, and then you have application as well. Now, when you want to give this application to your colleague or to your testing team or to your ops team, you can only give the software, not the entire OS. But what if you can do that? Virtualization says you can do it. You know how? We have hardware, we got host OS, on top of that we have virtual machine OS or virtual machine. So normally we can implement virtual machine with the help of hypervisor. And then on top of it, we can install Ubuntu, right? And on Ubuntu, you can build your application. It's a OS, right? So open Ubuntu, do all the things which you're doing, install your web server, install database, do all the configuration, you have your running app there. Now, you don't have to give just this software. What you do is you give the entire OS, not the Windows, the Ubuntu, the guest OS, which you talk about. Now, can you really copy guest OS? Yes, because it is not dependent on a physical hardware. It is dependent on the virtual hardware. Now, of course, internally it uses the physical hardware. So let's say if you want to even add two numbers on a calculator, which is on Ubuntu, your calc app talks to Ubuntu. Ubuntu talks to your hypervisor. Hypervisor talks to your host OS, which is Windows, and Windows talks to your hardware. So ultimately, when you're performing any operation, that goes to your physical hardware. But you can actually copy the guest OS because it is working on a software. So in these hypervisors or all these virtual machine softwares, they have a concept called creating an image. So what you do is, you have a running OS, the Ubuntu OS, you can simply save it. Literally save it. It will create an image out of it. Now at this point, it is difficult to understand image, but if you try to understand this, when you run your OS, it is running on your RAM, right? So all the components are open. When you want to give the OS to someone else, you create an image out of it. So you remove all the running part, you simply save a copy of it, this snapshot, the running snapshot of that OS, which is a file. And then you send a file to your any team, testing team, or your colleague, or your ops team. So make sure that they also have a hypervisor. Now these hypervisors are basically software like VMware. There are multiple options, virtual VM. So there are so many softwares. You can simply use those softwares. So let's say if you're using VMware, even they will be having VMware on their machine. They can simply copy this image which you have given to them, and they can run it on their machine. Now you don't have to send them the project or the configuration because they got the actual OS itself. That's how you can solve the problem. So problem solved, right? Now the thing is, when you give the OS to your testing team, they will test it. If something is wrong, they will give you the project back, and then you can make some changes. But what if everything is passing from testing team? Now you will send it to the production team. Now even they don't have to install any software. They have a VM software, like any hypervisor, and then you can simply run this on this server, on the production server, and it will work. If it works on your machine, it will also work on their machine, no problem. It's because now your software is not dependent upon the underlying hardware. It's dependent upon the underlying virtual hardware, which is same everywhere. Now you might be thinking, okay, so is it virtualization just came to solve your problems, developer? See, not exactly. Now, if we go back to 1960s or 1970s, if you want to make application to run on a server. Now servers are huge, right? They have huge amount of CPU, they have huge amount of RAM. Now if you run one particular application on that server, don't you think we are wasting so much of RAM, so much of CPU? So the solution here is, what if you can install multiple apps on one server, one physical server? But the problem is, these apps can actually talk to each other. It's not safe, right? Example, let's say you're building a banking application which runs on one server. On the other hand, your friend is working on some other type of application, let's say crypto exchange, and then both the softwares are installed on the same server, same OS. Don't you think it will be a risky part? So you need isolation there. So what we can do is, on normal servers, like we have physical servers, which are huge, you don't run one application, you run multiple. But then if you don't have isolation between application, it is risky. So what you do is, on all the servers, they install the hardware, the physical hardware, then they install a host OS, then they install a hypervisor, and then on this hypervisor, you can run multiple virtual machines, not one, multiple guest OS, okay? And in each guest OS, you can install one app. Now, since the OS are different, you got the isolation and your app are safe. So that's how basically virtualization got famous, but we can also use it for our purpose, right? Where you don't have multiple guest OS, of course you can use it for the production server, but as a developer also, you can build your application on a guest OS, and then you can give the guest OS to your to the other teams, other members. Do we have any problem here? Yes, there's a little bit of problem. Now think about this. To run your application, you are installing the entire new OS which you are giving to your team or some other team. Now don't you think you are wasting so much of RAM and CPU just to run that guest OS? I mean, your little bit of small machine, even if you're using i7 machine running 2 OS, will be a bit slow, right? So virtualization is good, but it consumes a lot of memory and CPU power because you're not just giving your software, you're giving the entire OS. There's additionally one problem, which is if you're using a host OS, you're paid for that Windows. And if you're using a guest OS, which is also a Windows, then you're again paying for the license for it. You need different license. Plus, if you're using a proprietary Linux-based distribution, again, you have to pay for the services and stuff. So that's a big problem, right? So it's good, virtualization is good, but there are some problems. Do we have a solution for this? And the answer is yes, we have a solution called containerization. Now let's try to solve the problem with the help of containerization. The thing is, if you talk about virtualization, what we have talked about is we have a hardware, on top of that we have a host OS, then we have a hypervisor, which is your virtual machine software, and then on top of that you have a guest OS. And on this guest OS, basically you have your application requirements, like say you have web server, databases, your compilers, everything installed on this OS. And then when you want to give this to someone else, you don't give the software, you give the entire guest OS image. Okay. Now to solve this problem, because when you say the entire guest OS, it's heavy, right, to run it. Now there's additional problem with the guest OS is what if you have multiple apps to run? So you have to install multiple guest OS, right? So on the hypervisor, you're not running one guest OS, but multiple. And don't you think there are multiple guest OS, which will be very heavy, let's say 5 to 6 guest OS for 5 to 6 applications. Now to solve this problem, we can use containers. Now, if you talk about the shipping industry, again, I'm not an expert in shipping industry, but let's say if you want to move some things from one location to the location through a sea route. Now, of course, you can just take this item, pack it in a box, and then send it to other place. Again, in the ship, when you want to carry it, you want to ship it. I know it's a very complex English here, which is shipping the ships. But the point is, when you want to again ship it on the ship, you have to box it again so that it will be waterproof, so that no water will get in, and then you will ship it to the other port, the destination port, and then from there on the trucks you will load it again and then you will ship it. The easier way would be, what if you can use containers? Now you have seen these containers a lot, right? So in fact, in one of my first project in a company, the client was a shipping company, so I don't want to name it, but so what they do is from the source location, when they want to pack things, they directly put the things inside a container. So let's say they have 10 boxes, all these 10 boxes goes inside a container. Now this exact container, the entire container goes on a truck, reaches to the source port, and then from this port, they will load it to the ship, and then they will dock it to the ship, and then from there, the ship will carry the same container. Okay, there's no unboxing and boxing happening here. The same container goes to the destination port, and then from there, the same container goes on, so it will undock, and then it will go to the truck, and this truck goes to the destination. Now, in the entire process, the things are moving inside a container. That is much easier, right? Now that's where this concept of containers came into picture. Now, can we do that in software? Now think about this. What if in the virtualization itself, or maybe let's remove virtualization, you have your hardware, physical hardware, and then you have your host OS. On top of it, you don't have to install any virtual machine, but let's say you use some containerization softwares. Now we have an option of like Docker, Podman, so there are multiple options. So what you do is you install this software, let's say Docker. Docker is powerful enough to run the container, not one container, but multiple containers. So instead of running your software on the OS, you are running your software inside the container. Now, from the developer's perspective, when you are building a project, you will not be building a project directly on your OS. You will make sure that your app is running on the containerization software, maybe let's say Docker. Now in this container, which you're creating on your machine, you have everything. You have your compiler, web server, database connections or database software, everything in this container. Now when you want to give this project to your testing team, you will not give the project. What you will give is the container itself. So this container goes from here, goes to your testing team, and then from there it goes to the production. You're not giving the project, you're giving the containers. And the beauty is, now, since you are doing this on Docker, the same container will go from your machine to testing team or tester's machine, and even they will have a Docker. Of course, they have to install Docker, and then you can run it. Now, installing Docker is not a tedious process. You just have to install one software, and then the exact container, the way it is working in your machine, will work on their machine in the same way. It same goes for the production server and also cloud, because most of the cloud applications supports Docker or cloud services. So basically what I'm saying is, when you build a software, build it in the container. The same container goes on there, and then from there, and then it works everywhere. Now, what are the advantages? First of all, containers is the isolation part. So if you run one application on one container, it will not interact with the other containers. Okay, so you have different containers running on the same OS. Now the advantage is you only have one OS. So the load on your machine will be less. Additionally, when you talk about virtualization, you have OS there, right? Starting an OS takes time. So let's say you are giving this OS Ubuntu image to your testing team. When they run Ubuntu from this image, it will take time. But what about containers? They are very fast to run because you're not running the entire OS, you're just running a container. And that's the benefit you get there. And by doing this, we are also making sure that you have safety, which is security. Also, what about portability? Now, since we are creating containers, it is much more portable, just like shipping industry. So you can basically port this container from one machine to other machine easily. What about scalability? Since you can run one container on one machine, you can run the same container in multiple instances if you want to scale it. And by doing this, we are also achieving consistency, which means if it works in your machine, the same way it will work on other machines as well. And that's the beauty of containerization. So basically, if you want to understand containerization, what it means simply creating a package of your software with all the configuration in a container and ship it to the other teams, other machines. Now, question arises, how will you implement containers? That will be done with the help of Docker. So of course, there are multiple applications or multiple softwares which can do this. But Docker is very famous. So we're going to talk about that in this course, and also the course name itself is Docker. So what is Docker? Now, Docker is a platform and a set of tools basically to achieve containerization. So we have talked about containers, right? How it can be helpful. And if you want to achieve that, we can use Docker. Now, how Docker does this? So Docker uses some components to achieve this. There are different components available. And of course, once we go ahead with the course, we'll understand all this component in detail, how it works, how do we create those, how do we configure them. But what are these components? Now, the first component we have here is a Docker engine. Now, this engine is basically responsible to do this stuff which we're talking about, right? Creating the containers, managing the containers, and as a user, how will you interact with the containers? So basically, we have to use some command line prompt, which you can pass some commands to interact with the Docker. Next, it provides you something called containers, and obviously, right, when you talk about Docker, it should have containers. So Docker provides you that containers concept so that you can run your softwares inside Docker. Next, we have an image. Now, of course, right, if you want to run a particular container, so as I mentioned, as a developer, when you do all the setup on your machine and you have installed the compiler, the web server, the database, all the configuration, and now you want to give this container to some other team or you have to install this on some other machine. Now, what you can do is you cannot simply give a running container, of course. So you have to give a image. Now, what is image? Image is like a blueprint of it. It's a lightweight file of your container, running container, which you can simply save it. It will create an image, and then you can simply use the image to run the containers on some other machine. So let's say if you get this image on your machine from someone else, you can simply run your Docker and load this image, and it will run the container. And with one image, you can run multiple containers, not just one, if you want to scale it. Now, question arises, how will you create this image? And that's where in Docker, we have to create a Docker file. How do we do it? That's a different things. We'll talk about that later. But we have to create a Docker file where you mention, hey, how do you want to create this image? Docker is good. It's very smart, but it's not that smart. It will create a Docker file for you automatically. So you have to mention what are the things we needed, what are the steps to run this project, and what configuration you need. So you can specify everything in a Docker file. Next we have is Docker Hub. Now from start, I'm saying that in this container, you can install the compilers, the installer, all this stuff, or web servers. But the question is, from where you will get it? And what if you want to run the OS inside a container? Yes, you can do that. How will you do it? So maybe for everything, you have to create your own image. Not exactly. So all these big companies, what they have done is they have created an image for their own softwares. Let's say if you want a web server, let's say Tomcat, you will get a Tomcat image. If you want MongoDB, you will get a MongoDB image. But question arises from where you will find it. Do we have to go to the individual website to download it? Not exactly. See, we are working with Docker, right? So I think it's Docker responsibility to have that repository where you will find all the images, and we do have it. There's something called Docker Hub. Imagine this as a cloud storage or the cloud service where you can get all the images. I mean, when I say all the images, most of the images. So if you want a particular image, just go there on Docker Hub and just download the image. Now, what about the networking? Now, when you are building application on your own machine, of course, your own OS has a networking component, right? So if you want to connect your two different services and if you want them to communicate, you can use your network protocols and services, right? What about containers? Containers themselves have their own networking components. So by default, everything works inside the container. But what if you want to connect your application which is running, or some application running on your local machine, let's say your Chrome, to the container? And that's why you have to expose some network ports from the container. So it provides you network component as well. Apart from this, what about the storage? So Docker provides you something called volumes. If you want to store data permanently, you can use the volumes of Docker. Now, what if you are building an application which will need multiple containers? So of course you can build application in one container, but sometimes you need multiple containers. Now, how will you do it? Now that's where Docker Compose comes into picture. So again, how do we compose it? That we'll see later, but we have this component. So all these components makes Docker. So what is Docker? Docker is basically a platform and the set of tools which we have talked about to run the containers so that it will be portable, it will be secure, and it will be scalable. Now question arises, how can we get started? And we'll also see how do you run a particular container. In this video, let's try to set up Docker. Now in this machine, I don't have Docker. Now how do I verify that? So what you do is you use your command line. So basically you can also check from program files, but let's use command lines because that's what we are going to use continuously. So to check, you can simply enter this command called Docker and then version. The moment you do this, when you say enter, it will give you an error by saying Docker is not recognized as internal or external command. So that means Docker is not there. So what we have to do is we have to install Docker. The way you can do that is very simple. Download the Docker and install it. I mean, of course, that's the obvious part, right? But how will you get it? It's so simple. You can just go to Google and search for Docker download. It will take you to the official website. In fact, you can just click on the first link. And from here, you can install Docker. Now, if you can see, there's a word which is Docker desktop. Now, what exactly Docker desktop is? The thing is, when you talk about Docker, it started with Docker on Linux, right? So we have talked about the Linux containers, right? So basically, we had Linux containers and somewhere Docker, the idea of Docker started with that. So initially, Docker used to run on Linux, but then we thought, hey, we have multiple OS, not me, but then the Docker team. They thought we have multiple OS, right? We got Windows, Mac. So how do I do that on this machine? So before, what they used to do is they used to install Linux on Windows because there was a support of Linux on Windows, which is WSL, and then you can install in Windows. So we have a layer in between for Linux, and it works on Mac as well now. And to support Docker on this OS, we got Docker Desktop. So the way you can get that is very simple. When you go to this website, you can see we have multiple options here. So if I go here, we have an option of Windows. So this is a Windows machine, I can use this. Or you can use it for Mac for Intel chip or Apple chip, depending upon which laptop you have or which machine you have. Otherwise, you can go for Linux. Let me show you how it looks for Linux. For Linux, you have to enter command. And people who use Linux, they know how to run commands, right? So you can just follow these steps and you should be able to install Linux. It's very easy. So just follow these steps. Now, since we are not into Linux, we are using this on Windows, and same steps applies for Mac as well. You can see we have an option of download here. So if I click on this, now, this is not the first time I'm installing Docker on this machine, so I should have this set up already. So you can see I already have a Docker setup. So I will just cancel this. In fact, I downloaded it in the morning itself. So what I will do is I will just open this. So this is how this setup looks like. So when I double click this, the steps are straightforward. Okay, so it will say, do you want to install Docker? I would say, of course, that's what I'm doing. Click on yes, and it should take some time to download because it's a heavy software. Now, depending upon how much RAM you have in your machine, because at this point, if I open Task Manager, you can see it is consuming already 73% because of the recording software which I'm using. But if I go back here, okay, yeah. So you can see it is installing, but after installing, it will take a lot of memory because Docker is a heavy software. Plus, the moment you start running your containers, it will consume a lot of memory. But what if you don't want to install on your machine? You can still do that. Okay, so if you don't want to run it on your machine, there is something called Labs, Docker Labs. Do I have the option on this? Let me check. So they used to have this on the page itself, but now I don't see that in the page. So what we can also do is search for Docker Labs, and you can see the first option is that. So it says play with Docker. I will just click on this. So if you don't want to install, you can directly access Docker from here. You can log in. Already have an account on Docker. Let me use it. Okay, so I had an account on Docker. You can simply create the account, that's free. And you can click on start, and from this, you can do whatever you want to do. So everything which we are doing, I mean, most of it which we are doing on the local machine can run on the labs as well. The only thing is I'm not using labs for this recording is because one session can only be for 4 hours. And of course, I will not be making the entire course in one go. Again, I have to do the same steps again and again for different videos. But if you want to try, you can try it out. So example, one of the command for Docker is, I want to check how many Docker images I have already. So when I do that, it says empty. So yes, you can do the same thing which you are doing on the local machine. But let's focus on the local part. So you can see it says Docker is installed properly. I will click on close and I will open Docker now. So I will say Docker, and you can see we got Docker desktop, and look at the memory consumption. The only thing I'm scared about using Docker on the local machine is because of the amount of memory it takes. So I feel 16 GB RAM is minimum for Windows if you want to run Docker. So accept, I mean, of course it will work on 8 GB as well, but it will lag somewhere. Okay, so you can see we got Docker desktop. I would encourage you to log in so that you will have the same setting on different machines if you are using. At this point, I will simply say continue without signing in, and it is asking for roles. I will skip this. And yes, we got our Docker up and running. So there's something called Docker Engine. We'll talk about Docker Engine later. But these are the options. Remember in the theory, we talked about Docker images, Docker containers. So at this point, you will see all the containers here. Images, you will see all the downloaded images you have. Volumes for the storage. If I go back to the images, you can see I can search for a particular image online. So let's search an image. What I will do is I will search for Linux, and you can see we have an option of Alpine. I will get Ubuntu. So I will click on pull, and now it will download this image. So we can also use this command here, which is docker pull. And you can see it says download the newer image, and now I can just run this. So run, and it should be running in the container. So if I go back to container, you can see it is running now. And the image, we already have an image now. So basically that's how you can get the image and make it run. So when you say image, you can see it's very lightweight. It's only 70 to 77 MB. But if I say container, it will consume a lot of memory. Okay, so it's not running. So we'll see how to run a container later, but you can see we got the Docker setup done, and we also able to get the image. Okay, so that's how basically you do the setup for the Windows. The setup is same for the Mac as well, and you can simply do the same step. And now if I go back to my command line, let's hit the same one. It is not working. So let's open our CMD once again. So sometimes you have to, most of the time you have to restart your CMD if you install something new. So if I say Docker version, you can see it says Docker version 24.0.4 or 6. So we got our Docker installed on the machine. Okay, so we have done with this setup, and now it's time to explore the Docker desktop, or basically Docker commands. So what we will do is, first of all, let me show you how Docker desktop looks like. And this time I'm using Mac. The steps are same for Windows and Mac, so it doesn't matter which one you use, you will find the same steps. Now, I have installed Docker on Mac as well. So there's the Mac screen. And if you can see, it looks similar. So we have containers here. So at this point, we are not running any container, and that's why you can say this is empty. When you download the image, you will find the images here. Now, basically, we have talked about this. Images are like blueprint. They are lightweight. And when you download the image, you only get this set of instructions which says, okay, if I want to run this container, these are the things I need. The actual working happens in the container. Okay, so container will be quite heavy compared to images, because images are just set of instructions and stuff. Okay, so we will get the containers here, we'll get the images here. If you are working with volumes, you will get it here, and those are things. And we'll explore all these things step by step. So let's focus on images now. So we want to get an image. Now, of course, we can create our own image, but let's get some images from the internet or from the Docker hub. Now, You can do this in two ways. Basically, you can get the image by searching this. So you can say search image to run, and you can search for a particular image which you want. Let's say I want MySQL, so I will search for MySQL here, and then you will see we have an option of MySQL here. Now this is official one. So you can see it says Docker official image. The other images which we have, example from Circle CI, it's a verified one, but not official. And if you go down, there will be some which are not even verified. Example, this one, this is sponsored OSS. And if I go down, so there's a list which you can find. We also have MySQL here, but it's not even verified, not even official. So you got the point, right? So try to get things official, which will make, which will always work. Now in this, if you can see the number of downloads we have, the number of stars it got, and the tags. Now basically these are versions, right? So example, if whenever you download any software, you do get the versions of it, right? So you can specify which version you want. Now here, when you say latest, it means the latest release. When you get the next release, this one will get a number. Okay, so now we have an option here. So if you can see, we have two options. We got pull and run. So I can simply pull it from here. Let me just try that first. So when you say pull, it will take some time to pull because MySQL is a bit heavy compared to the other images which we have. So it is pulling the image. And once the image pulling is done, you can go back to your images. This is where you will find it. So I think it is still downloading. And yeah, so we got our first image. So you can see it says MySQL created 3 months back. And this is a size. And you can also run this from here. I'm not sure if this will work directly without settings, but yeah, it says it is working. Let's see if I can see that in the container. It ran and it exited, but basically it was running at one point. So we got the images here and we got the containers here. But at this point, I don't want this. So let me try to delete the image first and let's see what happens. When you try to delete the image, let's say delete forever, it is giving you an error. It says image MySQL latest is in use. Of course, right? We are running a container. So it says delete the container first and then I will delete. Okay, that makes sense because if your container is running, how will you delete the image? So what you do is first you delete the container. Now that's gone. If I go back to images and if I try to delete from here, I can do that, delete forever, and now it will be deleted. So again, you can see this is empty. So this was one way, right? But most of the time we use commands to do this. We use commands to get the image. We use commands to run the container. Now the way you can do that is you can open your terminal. Now depending upon which OS you're working, for Windows it is CMD and for Mac it is terminal. So you can see I have a terminal here. And now I can run the Docker commands. Now first of all, we have to verify if I have Docker here. So I can say Docker version, and the version is 24.0.6, which looks like the latest version. And now I can basically run a container. Now instead of going for MySQL, which is quite heavy, I will go for some different example. There is one more image which I will first search and then we'll try to get that from there. And the image is hello world. Again, this is official, so we can use this. So we have hello world, which is created by Docker. And if I go inside this, this is the official image. And if I scroll down, so this is the output it will give. So you can say example output, this is what you will get. And how this image is created. So basically they have used, is it C programming? I'm not sure, maybe. Yeah, they have used C programming here. And yeah, that's how they're running the hello world. Now, how do I get this image on my machine? Because you can see the image is only 13 KB, which will be faster. So of course you can pull it from here, run it from here. I don't want to do that from there. So what I will do is I will go back to my command line. And how do I get the image? So you can simply say Docker and you can say run. So this will directly run the image. So I can say Docker run, and what I'm going to run is hello world. And if I say enter, you can see the steps it is following. So first it says, I'm not able to find the latest image. So you can see it here. So it says unable to find the image, hello world latest. So this is a tag. So with every image, you will also get a tag. If you don't mention the tag, it will go for a default one, which is most of the time, which is latest. But if you want another version, you can specify with a colon. Now in this machine, I don't have the hello world, and that's what it says. It says unable to find the image locally. Now, when you are not able to find this locally, what you do is you pull. Now that's the step you have to follow. So if you don't have the image, pull the image. From where? From the Docker hub. Okay, let me show you how Docker Hub looks like first. You can see I'm searching for Docker Hub. When I go here, this is where you will get all the image. Of course, I have to log in from my ID, or do we have an option of skipping? I think you can even skip. You can directly search for something here. So these are the popular images which we have. Nginx, we have MongoDB, Alpine Linux, Node.js, Redis. We also have for Java, Ubuntu, and then there are a lot of repositories available or images available. So if I go here and search for, let's say, hello world, this is what I was also getting in the Docker desktop, right? So this is all the image which we have, and you can get it. So as I mentioned, we have Docker official images, verified, and sponsored. And if you see the use, a lot of people are learning Docker by doing hello world first, because that's how you start. Okay, so this is the actual remote repository or remote place from where you are getting your images. And the beauty is you can create your own images and push it here. Okay, it's that simple. Okay, let's go back there in our Docker, or not here, on command line, and let's follow more steps. So it is pulling the image. Now, once the pulling is complete, you can say pull complete. You will get a ID for your image. I will show you the ID in some time. And it is printing some steps to follow, and then you can also run, if you want, you can also get Ubuntu in this machine. But here, if you can see, I got the image. How do I verify if I got the image? We have multiple ways. We can use it command line, or we can use the Docker desktop. So if I go back here, and if I say images, you can see we got hello world. It says in use because it is running. And if I go to the container, you can see we got hello world, which has done its work. And yeah, so, and you can see there's some name here, which is nice bog. Now, basically, every time you run a container, it will give a name to it. A random name, maybe they have used some algorithm to generate this name. But when you create your own image, you can give the name or when you run the container, you can also provide the name to it if you want, because that makes much more sense, right? If you're running multiple containers, how do you know which container you're looking at? So having a proper name makes sense. So this is how you can get the details of which image you got, which containers are running. But what if you want to get that from here, from command line? Now for that, you have to run some commands. Okay. Now, if you want to know which containers are running, we can say docker ps, and okay, none of the containers are actually running now because hello world ran and then they have done it. The work is done. But still, if you want to see the containers which are run, which have completed their work and exited, you can say -a. -a means show me all. And when I say enter, you can see this is the container which we were running. So the name is this. So this is the container ID. So every time you run the container, you will get an ID. You will get the name of the image. That's what we are running. The command you can use here is hello, and created 4 minutes ago, exited also. And then this is a name for the container. And I mentioned before, you can change this name. How, we'll see that later. But at this point, we got some name. Okay, what if I want to see the images I have? So I can simply say docker images and enter. And you can see this is the image I got. And every image will also have an ID. Okay, so we got the image ID. We got the running process or the running containers. But if you want to see the stop containers, we can say -a. Now question arises, how I delete this image, or if I want to delete a container, how will I do that? Well, let's see that. We will focus more commands and see how they work. Now let's see some commands to achieve the thing which we wanted. So first of all, we want to remove these containers, right? So we want to remove the container, we want to remove the image as well. But before that, as we know, whenever you use any tool, we have this help option, right? So what I will do is I will try to say docker help, and let's see, do we get any options here? So we have so many commands here. Of course, not every command will be used, but these are the common commands we have. So you can see we have an option of run, which we have already used, and we have execute. So it's execute a command in a running container. We don't want to do that now. You can use ps to list the container, which we have done already. You can also use build to build a image. Now, since we have not created our own project, or we are not building our own image at this point, we'll not be using this. Next option we have is pull, which we are going to see in this video. Also, we have an option of push, to push your own image to the registry. Remember, as I mentioned in the Docker Hub, you can push your own images, and the way you can do that with the help of push command. Then we have images, which lists the images which we have used. Then we have login to the registry and log out. So you can log in through the browser as well, which we can do using this button here, if you can see on the top, which is sign in. Otherwise, you can also do it from the command line. Then we have an option of search, which search Docker Hub for the images. Okay, we can explore this. And then we can see the version of Docker which we are using. We can also see the info. And yeah, there are multiple options here. But if you scroll down, there are certain things which we are going to use in this video, which is pause. We also have an option of RM. So RM basically means remove one or more containers. So that's right. We can remove containers with the help of RM. This is what I want. And we can remove the images with the help of RMI. So this remove images I. And then we can start the container. We can stop the containers. And yeah, so those are the things we have. So let's use this. Let's see if I can use those commands. Now, first of all, I want to remove the image, right? So I will simply say Docker, but let's try to remove the containers first. And we don't know the container ID, so I will simply say ps-a. And now you can see I got a container ID here. So basically what I can do is I can say Docker rm. So because to remove the container, we have to use rm and mention this ID. So I can just simply copy this ID and paste it here. When I say enter, let's see what you get. Okay, so it is removing the container because it is stopped. We should have first try to remove the image, right? Let's try that once. What I will do is I will just run this container once again. I will say run hello world. Okay, it's running. I will say clear. And if you see this once again, you do have a container. So what I will do is I will delete the image first. Let's try that. So Docker images, and you can see we have an image here. And now if I try to say Docker, now what's the option or command to remove the image is RMI. And then you have to mention the image ID. So I will just copy this and paste it here. Enter, and we got an error. The same thing we tried to do on the UI, right? The Docker desktop. And the error which you got here is unable to delete this particular image, must be forced. Okay, image is being used by the stopped container this. So this is the container ID which we have to stop first. So basically if you want to remove, first remove the container, which is dependent upon some image, and then remove the image. So let's remove the container now. So I will say RM and the same steps which we have used before. Let's copy this. And mind you, every time you run your container, it will get a new ID. So this ID is different from the earlier one, because in the earlier time, when we removed, you can see this was the ID. But now the ID starts with BEED. So this is different. Let me remove this and paste, enter. Now the container has been removed. How do I verify that? It's very simple. You can say ps-a and you can see everything is empty. So now we can happily remove the image. I can say enter and you can see image is deleted. How do I verify this? Let's say Docker images and there's nothing there. So basically using these two commands, let me just show you the commands once again. If you want to see all the containers, even which are running or stopped, you will see with the help of -a. Then we used a command which is Docker rm with a container ID to remove the container, and we can use Docker RMI with our image ID to remove the image. That's how you do it. Now let's say I want to create an image. So what I will do is I will simply try to start. So when I say start, what it means is the Docker container should be there to start. So let me try that. Let me say Docker start, and I will mention the container name as hello world. Now, first of all, this is wrong is because there's nothing called hello world. So basically, if you want to start something, because hello world is an image name, right? Not the container name. If you want to start, you need a container ID. Okay, I don't have a container. So let's create a container. So to create a container, we can say Docker create. But again, for create, we need to mention the image name. So let's say we are saying hello world. So from this image, it will create a container. And now you can see it is following the same steps which we have done before. So that means before create, because the create will pull the image, right? It is download the image. But what if I actually follow a proper steps here. Of course, when you say Docker run, it will do all the steps. But what if you want to do the steps one by one? So the first step is you have to pull the image. But I think we have already pulled the image, and you can see we got the image. And if I say the process or PS, we already got an image here. So what I will do is I will remove this container, or we already got a container. So let me remove this container and let's do step by step. So also remove, and I would to remove the image as well. The image ID is this, okay, which is same because the image ID will not change, only container ID will change. Now everything is empty. So what's the first step? The first step is to pull the image. Or maybe the first step is to search the image. So what I will do is I will say Docker search. It will search in the registry for a particular image. So I will say hello world. Do we have this image? Let's see. And you can see it is giving you a list of images here. And the first one is official. So when you say OK, that means it is official. And okay, O is going on top is because of we don't have enough space here. So you can see it says hello world is OK. That means it is official. So that's on top. And you can see so many stars we got. But this is what I want. So we want hello world. So yes, it is there. So that's the first step. Next step is to pull the image. So I will say Docker. We can use something called pull to pull the image. I will say Docker pull hello world. Now what it will do is it will download the image from the registry. So when I say enter, it says using the default tag latest is downloading it. It will take some time. It says pulling from library, hello world, pulling is complete, and that's done. Okay, so simple, right? So pulling is done, and let's verify that from the images. So yeah, pulling is done. But is it running? Let's see, or is the container created yet? No, so the container is not created yet. So the next step would be to create a container. So we can say Docker create, and we can mention the image ID, or we mention the image name. So let me just try with the name, enter. Okay, you can see it says created. I mean, it has given you an ID. Now this is the ID for your container. And if I say enter, you can see this is the ID. But don't you think there's a mismatch? We only got few characters here, and the ID is so big. So in the real world, the ID is actually very big. What you see here is only the starting point or starting part. Okay, so I got the image created, and now we have to run this. So to run this, we can also say start, and we can mention the image ID or the container ID. So the container ID is this. Let's try to use only the starting 4 letters. Let's see if this works, and it works. Okay, the container is running now. So if I say this, so it ran and it exited as well. Okay, so it is created and exited, and this is the name of the container which we got. Okay, and so this is when it was created. This is when it was exited 6 seconds ago. So that's how basically you can use this step. So the first step is search, and if you know it is there, pull, then you create a container, then you start the container. In fact, you can also stop the container, but it's already stopped. But if you want to stop a container, you can say Docker stop, and you can mention the container name or container ID, not the name. So we can just use this. Maybe you can use full or only part of it. Enter. Since it's already stopped, nothing will change. If I say this, you can say it is same because it's already into stop stage. You can also pause a particular container. So you can say Docker pause, and you can mention the container ID. It will pause it. You got an error because it's not running, right? So it will only pause when you're running it, or which is in running state. So if you have any containers in future, when we have running container, if you want to pause it, we'll see how do we do that. Or you can try it out. So everything is done. Now we can remove this container. So we know how to remove the container. We can say RM, enter. Now the container is removed. Let's verify, and it's not there. So basically these are the steps we have. So when you say run, it will do all the steps for you. Okay, so run basically is a combination of all the steps which we have done at the start. So yeah, these are the basic commands which we have, which we commonly use in Docker. In this video, we'll talk about Docker architecture. Now till this point, we have talked about a lot about Docker, what our different components are. Now let's try to summarize everything and also understand some new things inside the Docker. So what we have is when you open your Docker desktop, or even if you work with Docker, basically as a user, so let's say if you are a developer, of course you're a user as well. So if you're a developer, you need to interact with Docker. So Docker is this big component here, a big box. Now this is where you have to talk to it. So you cannot directly talk to Docker. So what we have in between is we have something called a client. Now this is your Docker client. Now this Docker client actually talks to Docker. Okay, so this is your Docker. And of course, the client is also a part of a Docker software because you don't separately install client, right? When you install Docker, you get everything. So yes, Docker client is also a part of Docker. And now on the other side, we also connect with the remote repositories, right? Or remote registry, right? So basically, if you want any particular image, you can simply search it on the registry and you can get it in your machine. That means we also have something outside this world, which is called a registry. Now, normally this registry can be public or private. Example, we have used the public registry, but this can also be a private registry. So let's say if you're working for a company where they don't want to share their images to the world, they can use a private registry. So this is connecting to this. So basically every time you interact with a Docker client connects with the Docker. Now, question arises, when you say Docker, what exactly we have inside this? Now, one thing we know, in this particular thing, we'll be having images, right? So we have worked with the images. In this, we'll be having containers. We have worked with the containers as well. In this, we'll also have something called a network component to achieve any network stuff. And then we're also going to have here volumes. Okay, this is a part of it. But apart from this, we also have one more thing here, which is called a daemon. Now, this is your Docker daemon. Now, basically, imagine Docker daemon as a background process. So every time you ask your client by saying, hey, I want to get an image, I want to run a container, who is responsible for it? Who is responsible to get the image? Who is responsible to run the container? Because we are passing all those commands, right, which we have learned before. Who is listening to it? So of course, there should be a process which is running behind the scene, and that's your daemon. And also, there's something called an API. So basically, when you send a request, the request goes to the API, and then this API knows, okay, this is what we need to do with the help of Docker daemon. And Docker daemon is responsible to get the image, run the container, configure the network, or if you want to connect with it, and also to create the volumes. So this is what basically happens behind the scene. So whatever steps we followed, initially when we said, okay, we want to pull the image, so Docker daemon will go to registry by saying, hey, I want the image, give it to me. So all those process of pulling the image, running the container will be taken care by the daemon. Now this Docker daemon is also referred as Docker D, which is Docker daemon. So the process which is running is Docker D. So yeah, that's about the Docker architecture which we have. We just try to summarize of whatever we have learned. One thing new is a Docker daemon, and every time now when you run the Docker, you will come to know who is doing that behind the scene. So till this point, we have used different Docker commands to get the image, run the container, stop the container, delete the container. So we have seen them, right? Now let's say, if you want to work with Java application, of course, to run Java on your machine, you need JVM. But also as a developer, you might want to use some other tools of JDK. So even if you want to run the application as a developer, you need to get JDK installed. So even to compile the files, if you want to debug, you want to profile. So for everything else, you need JDK. That means if you want to work with Java as a developer on your machine, you need JDK there. And now let's say you are building an application and now you want to give this application to your colleagues. So we know instead of, with the project, you have to also give the JDK setup. Now, we don't want to do that, right? We just want to give them one thing which will have everything, which will have your code as well as the runtimes. So that means I want to make sure that I create a container which will have my project, which we will do in some time, but also I need JDK there. How will you do that? So in this video, let's try to understand how do you get JDK and how do we use it. Now, when you say you want to use JDK inside a container, for what purpose you will do that? So let's say in JDK, after JDK 8, you got some new thing called JShell. Now in JShell, you can run your commands directly. So let's try to use that in Docker. So before going there, let's open a terminal and let's see how JShell looks like on the machine. So in this machine, I do have JDK installed. So JShell should work. So when I say JShell, now this is a JShell, which is a REPL for Java. And here I can run Java things. Example, I can create a variable int num is equal to 9, and this works. You can see we got a variable num, which is 9. Now we can also write our favorite statement, which is system.out.println, And in this, I can say hello world and enter. So you can see we got hello world. Now basically you can run Java commands here. Now I don't want to do that in my machine because in my machine I do have JDK, but I want to do this. I want JDK in Docker. So what I want is when I open Docker, I want to run this command. How do I do that? So if I say docker ps now, at this point you can see everything is empty. Okay, so I'm still in JShell. I forgot that. Let me come out of JShell. Okay, so now let me run Docker. So if I say docker ps now, you can see there's no container running. So I want to make sure I get the JDK image here. So I will get the JDK image. At this point, I don't have any Docker images. If you can see, it's empty. How do I get Docker image now? It's very simple. We can search for JDK image on Docker Hub, so or the registry. So I can say search for JDK. I will say enter, and you can see it will give you a lot of options here. So if I expand this, we have a lot of options. We want to focus only on the OK part. In fact, instead of JDK, I need open JDK actually. And if I say enter, okay, so now you can see we have some official images, and this is the JDK which we can use. There is also a JDK image which is this, which is from Eclipse, which is also official, so we can use that. But let's go for the first one, which looks good. Now, how do I get this particular image? Also, I want to know the tags and all those things, so you can just simply go to the Docker registry and you can get this. In fact, let me just do that quickly. So I can open my Docker dashboard and I want to go to the registry, search images. I want open JDK. You can also use commands, nothing wrong with that. But just to make the work easy, you can see we have so many versions here. So there are different tags available. Now, the only problem is we have to also make sure that this thing works on your machine. The thing is, different images are built for different systems. Example, this is Apple Silicon. So I basically need something which supports ARM. If by default on Windows or on servers, we have AMD 64, so it should work there as well. But I want to make sure that something which works on this machine. So you can see it says supported architecture is all these things, so this should work. Okay, so OpenJDK works on this architecture, so you should use something which works on all the architectures. And majorly we have these three. So in my machine I have ARM64, so I will use that. So this works. So I can simply pull this. So 22 JDK, I can copy this and go back to my command line. In fact, I'm talking about the first one itself. So I will say clear and paste this command, so which is docker pull OpenJDK :22-JDK, that's the tag. When I say enter, it will take some time to pull. Let's wait for it. Okay, so image pulling has been completed, and now we can check with Docker images. Enter, and you can see we got this image, and this is a tag, this is the image ID. I want to run this now, so I will just copy this and say docker run, and with the command OpenJDK. We can also mention a tag, so let me just go with the tag because we have different tags available, so I will go with this. Okay, it says it is running, and you can see we got JShell as well. But I want this to continuously run. I want to pass some commands. I want to interact with it because it ran and it came out. So example, if I go back to my Docker dashboard, and if I say the containers, it is exited. So if I want to run this continuously, what I can do is I can say docker run -d detach mode and it, which is interactive. Enter. Sorry, it should not be detached mode. It should be it. Okay, so not dit, it's only it. So we have to say interactive. So D is detached, so it will come out and it will work in the background. I don't want to work in background. I want to work in foreground. Right, so we got it, and now I can perform the commands. This looks like similar, right, which we have started earlier. So now I can simply say int num is equal to 8 and a variable got created. Let me try with system.out.println. Even this should work. Hello world, enter, and you can see we got hello world. So that's how basically we can use JDK inside a container. So basically this is a JDK, running on a container. But then what if you want to run your application inside this container? How will you do that? Because if you see a Docker PS, okay, we are still in J shell. I will say exit. Okay, so if I say Docker PS, and you can see this is still running. Status up about a minute. So this is still running. So I want to use this particular container to run my application. Now, which application? It can be a very simple application, or it can be a complex application like Spring Boot web app. How do we do that? Now let's try to create a Spring Boot web application, and let's put that in the container, in the same container where we have our JDK, right? But the question is, how will you create your Spring Boot web project? Now, of course, we are not going to create a complex project now. Let's keep it simple. Let's say we want to do something for Hello World. Now, the way you can do that is very simple. If you're using Eclipse with the Spring Boot support, you can directly create the project. Otherwise, doesn't matter which IDE we use, we can go to our favorite website, which is start.spring.io. And from here, basically, we can get the project. So go to this website, which is start.spring.io. And here you can select the project type as Maven and language is Java. Next, you have to select the Spring Boot version. I'm going for 3.1.5. Now, depending upon when you're watching this, you can select any version. And then the group ID. So I will mention group ID as com.telusko, the artifact as REST demo. Okay, and nothing much here, nothing to mention. We are saying jar. That's the packaging we want, because we want to package our jar file, whatever project you are making. So package into a jar file so that you can put that in the container. Okay, so it's literally that. For your project, create a package, a jar file, and then put that in the container. And the way you can do that is, first of all, we have to add dependency. Let me just do that step by step and click on generate. That's it, all the steps. And click on generate. Now this will give you a project. So it says generating, taking some time. Normally it will not take much time. Okay, so it says, you can see we got REST demo here, and let's unzip it and open in any IDE which you prefer. So unzipping done. Let me use IntelliJ IDEA. That's the IDE I have in my machine. So I will be going for a community version because not everyone will be having ultimate version. So let's go with community version, and it's opening IntelliJ. Now here we have to basically open the project. So I will click on open and just locate the project, click on open, and this will open the project for you. Now this is a very simple application at this point, nothing about Docker. We have Docker running behind the scene, but nothing to do with that for this project now. Okay, now in this project, let's go to our main, and if you open Java, REST demo application, now this is your code, right? Now this is a very simple code. It will do nothing for you. Even if you run this, it will run, but then you will not get any output. We want output as well to check something. So what I can do is I can create another file here, a simple class, and let's name this class as hello controller. And because I want to return something, right? So I will say public string greet. So every time someone calls a particular request, it should say greet. But what request I'm talking about? So let's say request is request mapping. And whenever you request for home page, this is what I want to display. Now what I want to display? I want to return hello world. Okay. And to make this controller, we have to make sure that you put at REST controller on top of it so that it will return the JSON format here. And that's it. Nothing much. You can see we got hello world and we got this application. The first thing is, let's run this app locally to check if it is working. Then we can go step by step, right? Okay, so right click this and see if this is working. I will just run this. Okay, we got an error. Looks like I'm running something behind the scene, which is creating an issue. So the port number is busy. Is there any container running with this port number? Yeah, looks like. Let me stop the other containers. Okay, so 8080 is still busy. I'm not sure where it is busy, but some application might be using it. So what I will do is I will just change this port number. So I can just go to application.properties and change it to server.port. is equal to 8081. Let's use this port. And now let's try restart the application. So we just have changed our port number and you can see it is working now on 8081. So I will figure out what is keeping this busy. But at this point, I got it. And now let's run this on a browser. So I got my browser here. And now let's run this on 8081. And when you say enter, you can see we got hello world. So this is working. Our application is running in the local. Now the next step is to create the jar file. Okay, that jar file is very important. So the way you can do that is this. So since this is a Maven project, as you can see, we got a POM file here. This is a Maven project. And in this Maven project, we have to mention one thing to get a jar file. When you say build here, you can mention the name of this. You can say this is REST demo.jar. So the final name we will get here is restdemo.jar. And anything else here? We can specify one more property here to specify our running class. So which is the first class which you will run. But it's also optional. Sometimes it works, sometimes it will not. So we'll see if we face an issue, we'll mention that. Okay, so looks like things have been set. Let me just restate this or refresh the Maven. Okay, now how do you create a package? Now, whenever you create a package, it will go inside this target folder. This is where you want your jar file to be. And to do that, we can use Maven here. So click on Maven. So Maven has different commands. You can use certain plugins to achieve that. Otherwise, you can just click here, which is execute Maven goal. So if you know how to use command line, because most of the IDEs have the same thing. If this is not there, you can simply pass a command called mvn package. Let me show you what that command is. Click here, and the command is mvn package. So open your terminal, run this command, mvn package. It will create a package for you. Looks like there's no error. There's some warning, but no error. And when you do that, you can see we got our jar file here, which is restdemo.jar. This is a jar file we have to use. But even before you use this, what we need to do is we'll stop this. Let's check in the browser. No, it's still running. So I will just come back here, stop it, and verify. Okay, it stopped. Now, basically, we got a jar file, right? Now, jar is basically a executable jar. So if you want to give this application to someone else to execute, you can simply give them the jar file and it will work. Now, that's the beauty about Spring Framework. Okay, but how do you run this? So click on your terminal, and the command you have to pass is this, java-jar, and you have to pass this, this name with the URL, the relative path. So you can just get the path for this, copy path reference. This is a path, and paste it here. So if you don't want to copy paste, you can type it target/rest/demo or rest-demo.jar. And when you say enter, this should work, and you can see it is running on 8080. Now let's verify if this is working, and it's working. So basically now we got a Spring Boot app, a simple app, doesn't matter is it simple or complex. We got the app, we packaged it, and now we are running it as a jar to get this output. But then I want to run this in a container, right? Now we have to do a simple thing. We have a container ready, we have a jar ready. Now where's the container? Container is here. If you see the dashboard, container is still running. We just have to take this jar file and put this in this container. Our job is done. How will you do that? So till this point, we got our container ready, and then we also have a jar ready. You just have to copy this jar and put that in the container. How will you do that? Okay, let's go back to container first, and we were doing that in the command line. So either you can do it in a command line, or you can do it in the, of course, in the terminal, but of IntelliJ itself, so that we are in the same path. Okay, so first of all, I want to stop this. I will stop this currently running jar. And now, okay, the mic is coming in between. So what I will do is I will open my terminal again, and let's play it out. Now, this is where I will put some command. The command I want to run is this. I want to check what are the processes are running for Docker. And you can see there is one process running. It's still up and running. And in this thing, we want to check the file system. Now, if you see your JDK installation, it will have multiple folders. Now, one of the folder we have to use is temp. So what we can do is we can use Docker execute. Now, we want to execute a command inside the container, And I want to see, let's say, all the files, all the files here. So I can specify docker exe, and then I have to mention the container ID or container name will also work. So you can see we got this weird name here, gifted Albacan. So I will just paste it. And then I have to pass a command here. Now, which command I want to pass? I want to pass ls-a. So it will list all the folders of JDK. So you can see this is the folders where you have inside JDK. You got bin, and if you go inside bin, you will see Java compiler there or Java C. But one of the folder which we can use here is temporary or user. It's your choice. I will be using temporary here. So how do we know what is inside the temporary? So instead of passing ls-a, we can pass ls/temp. And when you say enter, you can see in this particular folder, temp, we only have one folder. Anyway, we are not concerned about that folder. What we want to do is, we want to take our jar file, which is there inside this target. So you can see the jar file is here. I want to take this jar file and put this in the container. How will you do that? And for that, we just have to pass a command. So what's a command? So I have to say docker. I'll just clear this screen so that it will come on top and just give some more space here. So I will say docker. Now what we want to do is we want to copy, right? So for copy, we have to pass a command called cp, which is copy. Then you have to mention what you want to copy. So we want to copy. So we are in this REST demo in the folder itself, the project folder. And inside this, we have a target folder. Inside target, we have this file, which is called rest demo.jar. Now this is the file we want to copy, but where? We want to copy this inside the temp folder. So mention your container name, which is gifted _ something, and then give a colon, and then mention inside this container, I want to copy this inside temp. So I will say enter. You can see it says copied. Now, how do I verify that it is really copied? Again, we can run the old command, which is docker execute container name ls/temp. It will tell you that there are two folders. One was there already, and we got one more file, which is rest demo.jar. Copying is done. Okay. Now we got a container. Inside this container, now we have two things. So this is the container where you are running your JDK, and also you got your file. Now, if you want to give this to your colleague or someone, or to run this on a production, we can't simply give them the container, right? We have to give them an image. So how do you create an image of this container now? So to create the image, we have to use something called commit. So when you have to say docker commit, so commit is something which will create an image for you. So you have to say docker commit, and then you have to mention you want to create image of which or what. So you have to mention the container. So the container name is this gifted, and then you have to pass one more thing, which is the image name. So what the name of your image you want. So I want the image name to be Telusko REST demo, and then I want to give a tag as well. So let's say this is my version 1, which I want to say v1. Of course, you can use any name, doesn't matter. So I want to say v1. And when you say enter, it will still not work. You know why? It's because you have a container, right? Now in this container, you have a JDK. So by default, even if you run this image, it will give you JShell because that is by default configured. Let me show you. So I will say enter. We got the image ready. Let me see if the image is there. So I will say images, and you can see we got two images now. One, we got it from the registry. Second, which we created. I want to use this image. How do I run this? So I have to say docker run, and then you can mention your image name, which is rest demo, and then the tag, which is v1. And when you say enter now, so you can see it is running JShell. We don't want to run JShell. We want to run our project. Now, why it is happening is because if you see the default command for the container, so if I say docker ps, the default command for container is JShell. We don't want this to be a default command. I mean, we don't want to run this. Okay, how do we achieve that? So let's pass the same thing. This time we'll say version 2. And when you create the image, you can pass the command itself. Now, how do you pass a command? So to pass a command, we have to use cmd, but to make it happen, you have to pass an option called change. So to say change equal to cmd, which is the value. So I will put that in semicolon or single quote. Now in this, you have to pass a command. So what's the command you want to run? Now, how do you run a jar file? We have seen that before, right? You have to say java -jar, and then you have to mention the name of the jar. The same thing here, but you can't simply pass a command just like java -jar and the file name. What you have to do is you have to put this in double quotes. So put everything in double quotes as the array values. So you have to pass 3 values for the command itself. So if the command is of 4 words, you have to put 4 double quotes. Okay, and now we have to pass one more thing, which is a file name, which is there inside temp, which is rest demo.jar. That means when you run this particular container, the image now, it will run this particular command. And let's see if this works. Okay, there's no problem. Now, if I try to run this, but you have to make sure that you're running V2, because V1 was just default. We changed something with in the V2 version. Enter. Hey, it's running. I can say it's running. So it's running on 8081. So let's see if this works. I will go back to my browser and refresh. Oh, it's not running. What's wrong? See, the thing is, Docker itself, the Docker container has everything. It has the running softwares. It also has its own networking. It also has its own volume. So when you are saying that it's running on port number 8081, it's actually running on 8081 of the Docker network, not of the machine network. So machine has a different network. The Docker has a different network. So how do we expose it? So to expose it, what we have to do is, let's clear this. So to expose, we have to run one more thing. You have to specify the port number P, that the Docker port will be running on the machine port of 8081. So whatever Docker port you have, the container port will be exposed with the system port on the same number. You can change the number as well, but let's keep it default, the same numbers. And now if you say enter, so basically we are giving the port number as well now, so that it will be exposed to the outside world of Docker, which is my machine. And it says it is running. Let's verify and run, and we got hello world. We are running this inside a Docker container. Now, let's say if I want to give this project to run, I can simply give you this container, the image. I can push this image to the Docker hub. You can get this image and run. It will work. That's the beauty of Docker, and it will work on anywhere. It doesn't matter, right? So that's the beauty about Docker and running your images or running your application on Docker. So till this point, we were able to create the image, we were able to run the image in the container, and things are working fine, right? And we were able to get the output as well on the screen. So basically what output I'm talking about, we were getting this hello world. So when you refresh this, of course it's not working now because I've stopped the container, but it was working, right? We got hello world. But now the problem is when you want to create the image, we have done multiple steps, right? So what steps I'm talking about? I'm talking about these steps. So basically the first thing you have to do is you have to get the container for JDK, right? Because you have to run JDK. Now inside this container, we were able to copy our jar file, which we created, which was rest-demo.jar. Now it changes depending upon what you want to name it. And then you have to also mention the name of your container. So basically whatever container name you get that and you say, okay, I want to copy this in temp. And then you create the image. While creating the image, you say docker commit, and then you write this number of lines to create the image. And of course, nothing wrong with the line. The problem is how many times you will do this. Every time you make a change in your project, you have to do this manually. And that's a problem. Now you will be saying, okay, I can do this manually. But the problem is, this is a very simple project where we don't have a lot of different stuff. We just have one JDK, we just have one jar file and one running command. It works, we only have 3 statements. But what if you have different containers to work with? I mean, you have multiple images to work with. You have multiple commands you want to execute, multiple services to enable. And doing that manually every time is not a good idea. So we have to find a way to automate this. And the way you can do that is with the help of Docker file. So what we can do is we can do all those things, but then only once. And then every time you want to create the image, you can just run one command. It will create the image for you. I know that sounds like a lot, but not exactly. So what you have to do is you just have to create one file. So I will just minimize everything. You just have to create one file which is called a Docker file. So you have to click create a Docker file. Now in this IDE already have a Docker plugin installed. So if you have a Docker plugin installed, you will get this Docker file option. Otherwise, you can click on normal file and say Docker file, and that's it. You just got a Docker file now. Now in this, you have to mention certain things. The first thing is you need a container, right? Of which container you want JDK. So the way you can do that is using some commands of Docker, which is from, you have to mention the JDK, which is open JDK, and then you can mention the tag, which is 22 JDK, which we were using. So yeah, this is what you want. Next, you need to copy, right? The next command is copying. So how do we do that? In fact, you can also mention the maintainer name. So I'm using a Copilot, that's why it is giving you some suggestions. We can also mention that. I just skip it. Now, the next thing you want to do is copy, right? Now to copy, we don't have a copy command, we have an add command. So basically what you're doing is you are taking your jar file and putting that in this Docker. Okay, now when you say add, what are the things you have to mention? So you have to mention two things, the source and destination. Now, where's the source? Source is the target folder. So if you say target, we have our jar file here. So that's our source. So we can go with the target / the file name is rest demo.jar. And the destination is also, I want the same thing. So you can mention the same file name. Next, if you want to expose 8080, we'll talk about that later, but then we'll go for the next one. Next step is we want to create this image. But then while creating this image, we want to pass this command, right? This is the command we were passing, which is cmd, and then in the array, we are passing three things, which is the command itself, the java -jar and the file name. So you can put this command here, but then there's a different way of doing it. So to do that, we have to say entry, expose, entry point, and then you can mention your command directly, which is java -jar and then the file name. And you can say tab and it will work. And exposing is optional, we'll do that later. And that's it, only these three steps. Now what you're doing is, basically you're saying, hey, I want to get this image, which is OpenJDK. So when you say from, it means you want to refer to the OpenJDK image. Now in that image, when it runs, you have to add this jar file, and this is a path, this is a source path. And then you are mentioning what you want to do that. So when you want to run this, what should be the entry point? Entry point is this. And this is how you basically create a Docker file. As your project gets complex, you will have more statements here, but this is simple how it looks like. Now we got a Docker file and we want to create an image out of it. Okay, so we don't have to do these steps manually now because we have written that once. And every time you want to create image, you just run one command. Now what is that command? So you have to say Docker, not capital, you're not shouting at Docker. So you say Docker, and then you have to say build, because you're building an image. Now while building the image, you have to say tag. Okay, so we have to give a tag to it. As we have done before, we have given v1, v2 tag. This time let's go for v3, and remember that v3 is actually for Docker file. We'll say -t, which is for the tag. So I'll mention the name, which is rest demo, and then you can mention the tag here, which is by giving a colon, and you can mention this is v3, not v2, v3. Okay, that's done, right? Now you have to also mention the context or which directory you want to work with. So do you want to work on the same directory where you're working with? If yes, say dot. If you have a different path for the files, you can mention a path there, but at this point, let's not make it complex. Let's have the same directory. We got dot here. And that's it. You say enter, and you can see we got an image, but the real question is, will it work? Now, if you look at the steps here, what step it did, if I expand this, so you can see we got docker build -t, this is the command we have passed. And then it says, okay, let's start the step. So it was quite fast. Let me know how fast it was there on your machine. But we are saying that load docker.ignore. Now, there are certain files which you don't want Docker to take care of. You can mention those files in Docker ignore. If you have used Git before, we also have Git ignore, right? So something similar. Then you specify it. So it loads the definition from Docker file, so it will read the Docker file. It will also load a metadata for Docker, the OpenJDK which we have used, and then it will start building now. Now for building, it has done here. You can see it has taken some memory for metadata. Okay, so then it will get the Docker for you JDK. It was quite fast. I think it's taking from the cache. Now what is cache here? The thing is, since we are using this packages and images and this jar file multiple times, it has created a cache of it. You can see it says from cache. So this is getting it from cache and then exporting the layers. And at the end, it is writing the image, and that's what you got here. And this is the name for it. Okay, so we got the image, and I can also confirm that by saying docker images, and you can see we got all this image. This is the image which we created, which is v3. And now let's run this and let's see if this works. Let me just run this Docker images one more time. And now let's run this. So it's a Docker run with the same command which we have used before. So we have to also expose the port. I will go for the same port, which is 8081 and 8081. And then you mention your image which you want to run. So the image is Telusko -rest demo. And then you also mention the tag, which because we have multiple tags, right? We have v1, v2. Let's run v3. And now when you run this, I hope it will work. So it is running, there is no problem. It is running on 8081 port number. Let's go back to our browser and let's see if this works. Reload, and it works. So basically what we are doing is, this time also we are getting the image. The only thing is we are doing that with the help of a Docker file. We are not doing those steps manually. Okay, so that's how basically you create an image from a Docker file, and that's how basically you create a Docker file. So let's continue our journey on Docker. Now till this point, we were able to get the images, run the containers. In fact, we were able to run a Java application on Docker, and not just normal application. We were able to run a Spring Boot web application. So if you see the code which we have done before, we had this REST demo application where we were doing only a simple thing. We were able to get this hello world, and things are working out. So we were able to get the jar file. We have a running container of Java. We were able to put that jar file there. Everything was working, right? And it's still working. I have not stopped the server yet, or is it stopped? Maybe. The point is, we are getting everything in the container, right? Now you can take this container and you can take it to any cloud and you can push it there and it will work. Or you can give it to someone else. This image, you can give it to someone else and it will work. They'll be able to run this Docker. Now here's the problem. See, in the real world, we basically work with databases, right? Or different services. In this, we just have a Java application with Spring Boot stuff and things are working out. But what if you want to connect with database? What if you want some extra containers? That's right. So in one particular project, you'll be having multiple containers. So what if you have multiple containers? How will you deal with that? And that's where we are in this particular video or series of video, we are going to focus on how do you run multiple containers? One container for our application, one container for, let's say, database. Now database, DBMS can be anything. You can use relational databases or NoSQL databases, your choice. In this video, I'm going to use a relational database, which is Postgres. Now the configuration is similar to different databases. If you want to use them, you just have to change the line where we provide the connection string, username, password. Everything else remains same. Now, so let's say in this, we are going to run two containers. Now, when you have two containers, how will you run those two containers? And then we ran some command and it was working. Now let's try to use something called a Docker Compose. Now, of course, we'll not do that in this video. Let's go step by step. Initially, we need a project, right? So a simple Spring Boot web project where you can have a database connection, let's say Postgres. And then we'll try to move it towards Docker Compose and how do we run this too. Okay. Now, to achieve that, what I'm going to do is, let's create a new project. So create a new project. I will go back to my browser. And here, let's go to start.spring.io. And then we'll select a Maven project. Let's keep it Java. And the version is 3.1.5, which we are using from a long time. And then let's say this is Telusko and this is Spring. Of course, it's just web application, but let's say Spring. Or what should I name this project? Let's say student app. So basically we are going to create a Spring Boot project where we can manage students, right? Say add students or delete students. Now based on 2 or 3 parameters, let's say 3 parameters, ID, name and age. Let's go with this 3. And you can see we are getting a jar file with this version 17 and the dependencies we have to add only 2. One, we need to add a Spring Web. And next we need to also add the JPA, right? Why do we need JPA here is because we want to store data in database and you can use normal JDBC or we can use something called a ORM tool, let's say Hibernate. And to make it more easy, we can use Spring.jpa. Apart from this, I also need a Postgres driver is because I will be using Postgres as my database. If you're using MySQL, use MySQL here. And any other database, you can use that. Just this 3 and click on generate, it should work. So you can see we got the project here. Now what I will do is I will just unzip it and open that in the IntelliJ IDEA. Okay, so I'm going unzipped it. Let's open that with IntelliJ IDEA. Okay, I want to open that in this window. Yeah, let's go with this window. Or maybe we can just say new window, because maybe we want to refer something from the old project, right? We can just copy paste. Okay, so we got these three things here. If you can see the POM file, we do have Postgres, we do have Spring Boot test, which we are not going to use now. And then we got data JPA, we got the web starter. Things are looking cool, but we are only doing it for the simple project, right? Okay, so now let's do something here. What type of service I want? So basically, I want a controller which will return me the list of students. So I can say this is student controller, and this will return what? At the rate. So I want this to be a REST controller. And what else? Okay, I need a method here which will return the list of students. So when I say list of students, let's say in my database, I have multiple students, right? So I can say list of student, and I will say get students, which will return a list of student. But unfortunately, I don't have a student class. And okay, it's just because I'm using Copilot here, it is giving me suggestions. Maybe we can use it or not, that's a different thing. Or maybe let's use it. So first of all, let me just get this class, create a student class in the same package. Yes, student app. And here I'm going to say this will have three parameters. One is int ID. Okay, just giving me a suggestion as well. That's great. Sometimes it's good to use the AI tool. Okay, but I don't want course. AI is thinking ahead of me, which I don't want. Okay, so basically you can see we got three variables here. And for this, we need getter setters. Of course, I can use my IDE to do that. I don't want to use the AI tool now, because you can see this giving me suggestion of the constructor after the class. That's not right. AI tool has a lot of time to evolve. So let's say we are using these three parameters or three variables. We need getter setters. Also, I need a toString. Maybe I want to print those students. So I will just right click here and say generate a toString, click on OK, and that's it. You can see we got a student class. Let's go back. I can also make this as a component, but normal Pojo should not be a component. Okay, so I want to import the list, and here I want my AI generator to give me some suggestions. Okay, so at this point, it is returning a list of students using some names. It is also referring Ranga, who is my friend. Okay, we can go with these names, that's fine. Why we are getting an error here? Because we don't have a constructor. So what I will do is I will just go back here and I will say, hey, I need a constructor. Right click, generate constructor for these three parameters, and done. Let's go back here, no problem, and you can see it should work now. And now to test it, what I will do is, okay, we have not assigned the request mapping to this, and I want this to be done whenever I say get students. So when the request goes for get students, it should return this list of students here. Okay, so now there is no problem, I think. Let's run this and let's see if this works. So I will just go back to the application and run. Okay, I got an error. Now the problem is I can't run this, unfortunately, is because we are using this data JPA. So at this point I can just comment this part so that we can get the data. So I will just run this. Okay, I've commented it, but I forgot to do manual refresh. Let's rerun. And there should not be an issue now, or there is an issue. The port is busy. Okay, a lot of problem to solve. So it's just because we are running a lot of projects here. So let's go with the server port. And this time, let's go for the port number as 8090, because I think that's the port which is free for sure. Let's run. And you can see it is running now. Let's get back to our browser to test it. So this time we'll not go for 8080, it is 8090. Enter. Of course, we are not set anything for the home page, but we set it for the get students. And when you say enter, you can see we got this three data, and that's good. Okay, this looks good. Now let's go back here. And now let's try to connect with database. And for database, of course, we need few more files. And we should be using proper packages for controllers. It should be in controller package. The another classes we're going to create now is service. It should be service package, but Since we're into learning stage, we can write everything in one place. It is easier for you to see what I'm doing. So I will say student service because I want to perform some operation, or I can directly work with repo since I'm lazy. And I want this repo to be interface, and this should be connected, or this should be implementing code repository, or maybe I can go for JPA repository. Okay, now for JPA repository, I have to uncomment that once again, the POM file. Okay, so uncomment that, refresh your Maven, and go back to repo. We should be getting the JPA repository. We got it. And now, basically, we need to make sure that you open this. Okay, looks like we do have a problem. It should be extends. Okay, it's just because initially I went for the class, and that's the thing I was having in my mind. Anyway, so we got this student repo, and we know the power of JPA, right? Where you don't have to write any methods. It will give you some default CRUD operations by default. So let's use them. The only thing I will do is at the top of this, you have to say add repository. Now for the production, you should not be doing directly this because I'm going to use this repo directly in the controller. You need to have more layer in between. So let's say service layer. But since we want to make it fast, we'll go for this. And I want the hold on this repo. So I will say student repo. And on top of this, I will say auto wired. Okay, so things are looking good. It should work. The only problem is, even if you run this code, it will not work. You know why? It's because nowhere we have mentioned the database to connect with. And that's what we are going to do now. How do you mention things which using, okay, why we got in different language? That's weird. So basically we have to set up some database configuration. Now what are the configuration? Of course I can type it or I can just copy paste it so that we can make it fast. Okay, now this is a general configuration for your Postgres. Now even if you're using MySQL, we can use something else. So basically for MySQL, you're going to use MySQL here. Since we are using Postgres, we are using Postgres now. Okay, but then we want to change something here. Now, since we are working with the Docker, so we want to make sure that we run this inside a Docker container. So what are things we need? So basically we will need different things here. But at this point, let's think about Docker a bit later. I just want to make this work. Now this is my username for Postgres. This is my password for Postgres. And that's my database. Do we have a database? Let me just verify that. So what I will do is I will open pgadmin. Okay, waiting for the password. That's the password. And now, basically I was doing some testing for the Docker, and that's why we have this Docker here. But I want to make sure my pgadmin is working. Okay, so you can see I have a lot of databases here. We also have a student database. We're not going to use that. I want to use this Telusko database because in this, if I see schemas and if I look at the tables, okay, I do have some tables here, but we're not going to use those tables, right? We want a student table. So things are there. Basically, I do have the service running. So what I will do is let's try to run this and see if this works, or are we missing anything? Okay, actually we are missing. So whenever you want to store data, you need to make sure that you have @entity on top of it. And this should be your primary key. So we can say that with the help of ID. And we want it to auto-generate the primary key. So I will say generated value, strategy, and this is what we want. In fact, you can import this also instead of having the qualified name. I just want to import this. Okay, so this is how you complete this. And now let's run this and let's see if this works. I will go back here, run, okay, yeah, stop and rerun, and we'll see if something is missing, we'll add it. Okay, looks like there's no problem. Let's go and verify with our browser. Okay, so if I refresh now, okay, I'm still returning, okay, things are not done yet. So what we are missing still is we are returning the hard-coded values. What we need to do is we need to say return repo.findAll. So this will return the data from database. So now, if I rerun this, okay, no problem. Let's go back to the browser and refresh. Okay, so you can see it is empty because we don't have any data. But also, I want some data. Because if you see, one of the configuration which I've mentioned is if I go back to the application properties, I've mentioned that I want to load some data. Okay, some predefined data which I want to use. Okay, so we have to also make sure that you load data. So we have to put this one extra line here, and this is applicable for Spring framework about anything about 2.5, Spring 2.5 or Spring Boot 2.5. Okay, so now I just need to mention this, but I want some data as well, right? Default data. I don't want to enter data by myself. So what I will do is I do have the data file with me. I will just get a data file. So basically what you do is you just have to create data.sql file, which looks like this. And I do have some data in this, some insert statement, which will be by default will be there. And by doing that, if I restart now, I don't want this message every time. You can see there's no problem. And if I go back to the browser and refresh, okay, we got an error. No default constructor. That's right. We are creating an entity, so it should have a default constructor as well. Okay. And now let's rerun. Go back to the browser, refresh, and you can see we got some data. We got a lot of data here. I think it's loaded 2 times. That's the issue. Anyway, we are getting data. That's what we are concerned about. Right? We are not concerned about how we got those 2. So basically, it is we ran it for 2 times and it got entered in 2 times. Doesn't matter. But basically, we were able to get the data as well, right? And that's important. Now, this is your simple web app where you have Spring Boot web app, you have data JPA and Postgres. But now, what I want to do is I want to containerize it. So I want to make sure that this project runs on Docker. Basically 2 different containers, one for the app, one for the Docker, one for the Postgres. How do we do that? So now we have our Spring Boot web app ready with the database as well, which is Postgres. And what we are able to do till now is we are able to run the project. Of course, we have written the code so that we can get some output on the screen. And then the data is coming from database. In fact, we have also created this data.sql so that we can get some initial values. And then if I go back here to see the output, you can say this is the output we have. And of course, things got added 2 times is because we are running this multiple times. And every time you run this, it will load that data.sql and it will fill up the data. But in real world, we don't do that, right? We have, when you start a project, you will have some dummy data, which you will insert in database, not from the code. And then as you keep your web application live, people are going to join, they're going to register themselves, and that's how it works. But here we're just using some initial file and that's what is getting loaded. Anyway, that's not the main concern. The main concern is we have our app ready and now we want to Dockerize it. Basically, I want to run this on a container. We have seen this before, right? We were able to run a hello world and we were able to run that on a container. But this time things are different. It's because we have our application, plus we also have a database. And I want to run my database on a separate container, okay? Now that will be tricky, right? So just be with me and see what I'm doing. The first thing is I want to Dockerize my application first. Now the way you can do that is we have seen that we have to use a Docker file. Now how do we create that? So what I will do is I will just use the Docker file which we had used earlier. And I think I do have a project open here, res demo. So let's use this particular Docker file, if you can see here, and I can just copy this because we know how to do it now. Okay, where is my IDE? I want to paste that in this project. So I'll go back to my home page, paste, and I want my Docker file to be here. Okay, Docker file is here. The changes is we don't want to name it as res demo now. It should be something different, something for this project. Now this is your student app, so I want the same name. And if you want a shorter name, not the bigger name where you have a snapshot or something like that, because see, if you don't mention the name for it, by default it will pick up the name which you have mentioned here, which is artifact student app, and then this version is so big. So one thing you can do is you can just go back here in the build, you can mention the final name, and you can mention this is as a student app, so that the jar file which you'll get is student app, and that should be in target folder. So if you look at target, it's empty at this point. I mean, it's not empty, but we don't have a jar file yet. Okay, so the first thing is I want to get the jar file. How will you do that? First, whenever you make changes in your POM file, you have to make sure that you load your Maven changes. If you're using IntelliJ, you will get this option here. If you are using some other software, let's say in Eclipse, you can right click on your project and you will see an option of Maven, and then you just refresh. Okay, so now if I want to create a jar file, I have to run a command which is mvn clean package. So I can just go back here, execute a Maven call, and I want to run mvn clean package. This is what I want to run. So when I click this, it will first of all clean the target folder, and then it will start creating new things. So as you can see, we got a lot of things, but we got the jar file. This is what we wanted, right? Now, once you got the jar file, you can run that on a container. So we can do that. We have done that before as well. But this time, I want to use something else because we want to run 2 containers. And when you want to run 2 containers or more than that, it's a bit tricky. So one of the solutions we can use here is Docker Compose. Now, Docker Compose is basically a tool which is there. It's a part of Docker Desktop, which you can use to work with multiple containers. How we are going to use that? Do we have to install something else? Not exactly. And the beauty is you can run multiple containers, or you can stop multiple containers just with one command. That's what we want, right? We don't want to run multiple commands. Okay, we just want to run one command which should do everything. And to achieve that, we have to use Docker Compose. So what we can do is we can just go back to terminal and we can say Docker Compose up. That's it. This is the command you have to use. And if you want to build your project, because we have not built the Docker image yet for the project. So what you can do is you can use a double hyphen and you can say build. But the moment you do that, it will give you error. It says no configuration file provided, not found. Okay, basically Docker Compose up will work provided you give a configuration. You have to mention, right, what containers you want. It's not magician to know everything. So it is magic, but then we have to provide some configuration. And the way you can do that is by creating a file called Docker Compose. So the file name is Docker compose.yml. Now this is a YML configuration which is much better to work with compared to properties. Is because when you have property files, and if you want to mention URL, username, password for the same parent, you can see the parent is same, spring.datasource, spring.datasource, spring.datasource. In fact, in YML, it helps you to reduce the number of lines. So basically, if you want to do this in YML, this is not a YML file, but if you want to do that, you can simply say spring : and you can mention data source only once, and then you can have a child elements to it. You can say, this is the suggestion which we got. You can see, you can mention the URL, username, and password, just like this, instead of these 3 lines. So you can see the number of words which we use become less, because now we know that URL is a part of data source. Username is a part of data source. That's how you do configuration for your YML. In fact, you can convert this application properties to YML. That also works. A lot of people prefer YML. But let's do it for the Docker Compose here. Now, what are the things you have to mention? The first thing, you have to mention the version number. The version we can mention is the current version which I last worked with is 3.7. You can also try 3.8. It might work. So I think the new one is 3.8. When you're watching this, after some time you're watching, you might be getting a different version. Next, you can see I got all the suggestions here, and AI tool work. So let's type it. So for this project, what are the things you need? So you need 2 things, right? You want to run your application, plus you want to run the database. And all this are part of basically a service. So I can say services, and then what you want to do. So first I want to build an app, not a web. Let's say I want to, okay, so we got everything. I will just remove this. This is the AI suggested stuff. Let's type it. So I will say this is app. I want an app. And in this app, what we want to do? So the first thing we want to do is we want to build an image for the project. Now the image is generated with the help of Docker file. So this is a file who is responsible to do that. Okay, we forgot to make changes here. So this should be student app.jar, and I can mention the same thing here, student app.jar. And when I want to run this, it should be student app.jar. Okay. Go back to the YAML, and here we have to mention, first thing I want to do is I want to build it, right? So that's the build. And what should be the command? So we can mention the command as well, but let's do that later. And also, remember when we were running the application, we have to also expose the port. So we can do that with the help of ports here. And I want to expose, let's say, not 5000, but I want to expose 8080 or 8090. Remember, that's what we were doing. 8090 to the container port number 28080. Let's use that in container. So this is the host port number and this is the container port number. Okay, so these are the two things you have to mention in the app. Next, let's focus on the Postgres. So we want Postgres as well. So we can mention Postgres here. So we want to run two containers, right? One is app and one is Postgres. The first thing you have to mention is the image itself. So I will just use image : I want to use Postgres, but then I want to use the latest version, not the version which is mentioned there. I'm not sure what's the latest version, but it should work. Next, you have to mention the environment variables. See, whenever you connect with any database, you have to provide some things, right? Example, if you go back to the application properties, these are the properties we have mentioned for Postgres. This is the URL, that's your username, that's your password. But I don't want to use this username password for my container. Because see, these settings are there for my Postgres, which is installed in this machine, not on the container. But if I want to run a container, I want to use different username, different password, and different database maybe. So I will mention all those things here. So I can say environment. And the first thing I want to mention is I don't want user to be Postgres. I want user to be Naveen. I want the password to be 1234. And database is, let's go with Telusko. Next, we have to mention the port numbers as well. As you know, in the application properties, we have also mentioned the port number. But the problem is this port number is busy for my one server. I don't want to use the same port number. So for Postgres, which is installed in this machine, I can use some other port numbers. Let's say 5431 for that matter. So I can say ports, and I will expose 543, let's say 33. And for the container, I want to go with 5432. I just want to use a different port number than the port number there in the system. And that's it. So what we have done is we are mentioning that we want two containers, not one. We want app, which will run in one container. We want Postgres, which will run on another container. Okay, so will this work? That's something we have to explore. Let's see. Let's try and see if that works. That's how you learn, right? That's how you know something will happen. Since we have changed our, did you make any changes? No. Okay, so we can directly run. This images. So I can say Docker compose up build. Let's see what happens. See, this time it is not giving error by saying not found. It found the container. It is also creating the container. That's great. Okay, let me just check the Docker images. Okay, so I was doing some experiment before. Yesterday I was doing some experiment. And you can see this is what I'm talking about. So this is 8 seconds ago. And we got student app. That's the image which we got. And also, okay, it is giving error is because, okay, so if you can see, we got an error. It says the project is already running. Oh, that's right. We should have stopped it before doing this. Let's do that once again. It's because we forgot to stop the running process. So you can see when I do that build again, we got some weird errors, and there are a lot of errors. And we love errors, right? So if you can see, the error is because it's not able to launch properly. Okay, now this is the problem. This is, okay, before this also we have problem. Let's try to understand that first. Let's go to the topmost position from where we're getting this problem. You know, debugging is a skill which you have to learn first, then do all those things. Okay, so you can see it says the connection refused. Now this is a problem. The problem is, see, when you talk about Docker, and when you say you want to connect to a particular network, and as we mentioned before, Docker itself will have its own network. Docker will have its own storage, right? We have seen that. We have Docker networks, Docker storage in the architecture. So they will have their own network. So basically, we want to make sure that you're able to connect your network, which is in the computer, which is the outside network, with the Docker network. So somewhere we have to create that connection. Plus, we have two containers, and they are running in their own networks. So every container will have their own network. How they will communicate? And that's where the problem starts. How do we solve this problem? We have to make some changes. And what changes? We'll see that in the next video. So in this video, we have talked about how to create a Docker file, how to create Docker compose YAML file, and the required configuration. Again, this is not complete. We want to make it work. And as I mentioned before, things are a bit complicated in terms of configuration. But again, you do this only once, right? for the entire project. Okay, so let's make first few changes to make this work. The thing is, of course, it will work after so many changes, but let's start with the first one. See, by doing this, when you say you are running two containers, which is one is your app and second is your Postgres. Because see, when you say services and when you say Docker compose up, it will look for these services by saying, okay, I need to make sure that I run two services, this one and this one. It might be working behind the scene, but they're not able to connect. Reason being, if you see your application properties, look at the configuration here. You are still connecting with your local machine. And here we are running a Postgres container. So the first thing change we have to make is instead of this localhost, we have to make this as Postgres, because we want to say that you have to connect with the container, not with the localhost system. Next, for that particular container, when you're running Postgres, the username is different, right? The username is Naveen. If you go back and check, the username is Naveen. The password is 1234. The database is same, Telusko, so that should work. And the password is 1234. So these are the two changes you have to make first. And then go back to your compose.yml and let's see what is the issue. So what I will do is I will just do the process once again, the same process, and see what different errors we get. I'm not expecting it to work, but at least the error, let's go step by step, right? Let's work with the errors. Okay, it's not able to create this file. Okay, so what's wrong? Why it is not able to create the file? So if I go back here, it says the Postgres is not available. So we have to make sure, it will give the problem with that. Okay, so there's one thing you have to make changes. What you do is you skip the test to make it work. So if you're using Maven, you can pass a command by saying -d skip tests. If you run a command like this, so clean package, and then you can mention -d skip test. This is one way. Another way is you can disable the test from here. So if you can see, there's a button here, which is skip test. And let's build it now. Again, this is not for the production way, but you can see we have built it. So there's no problem with this. But now let's see if the Docker Compose works. So let me clear this. Okay, still running. Let's stop it. Okay, so we have to make sure that before getting the container started, down it. And you can see the stop. Now do up build. And let's see what other problems you get here. So looks like things are working out. And do we got any error? Okay, there's no error. That's good to know. Okay, initially we were getting some errors, but now there's no problem. Let me just check. If I go back to my browser and refresh, it's still not working. Okay, what's the issue? If you go back to the output, it is not showing any problem. So the problem is these two things are not on the same network. So we have to make sure that our app, so we do have two containers. Let me show you that. How do I get to see those two containers? I have to open a new terminal. So I will say Docker PS. And you can see we do have these two containers up and running. They both are working, but they're not on the same port. Okay, so they are not on the same network, not the port. How do you get them on the same network? So what we can do is we can have something called a network. So we can configure the network and we have to make sure that both of these are on the same network. So Docker does provide you an option of networking. So you can mention the network name. I will say my network name is my network. You can go with any name, doesn't matter. And then you can mention the driver. By default, it will be bridge and which should work. So example, if I say Docker network ls, you can see we have few networks here. Okay, this is the network which I've created yesterday for experimentation. Or maybe we can use some other networks. Let's not use my network because it is already used. I will say this is S network for the student network. And now when I do this, it will create a new network for us. But you have to also make sure that both these images are running on the same network. And to do that, we can write one thing at both the places. So we can mention networks, S network. The same thing we have to paste in the Postgres as well. So networks, and now it should work on the same network. Let's see if this works. I will just go back to my terminal, stop it. Again, say down on the safe side, it will remove it. And let's build again. Okay, no problem. There's no error. If you scroll up, there's no problem anywhere. Let's go back to the browser, refresh, still not working. Okay, so we are exposing on 80, 90. Okay, so it was running on a different port, but then we got 404. Let's do one thing. Let's run on the same port. Is that the issue? Get student should give you the list. Let's build once again. Clean package. Let's run it once again. Okay, so we got it. So now if you can see, we got the output. I think the problem was with the port number. So I'm running on the same port now. If you see the Docker compose file, something was wrong with the ports, I think. So now things are working out. So you can see we were able to get this data from database and things are working out. And that's good to know. Okay, now what I will do is, so basically what we have done till now is we got a Docker file and we got Docker compose in which you are able to run 2 containers. And if I show you those 2 containers here and also see the network, this time we have created new network, right? So these 2 are actually working on the new network called S network here. So if you can see, we got a new network called S network and these 2 are running on the same network and they are able to communicate. Don't worry about the source code. I will give you the source code on GitHub, so you will get it. But this is how it is working. So you can see we got S network here and this is working. You can see we got the output here. So what we have learned till now is how to run 2 containers or multiple containers using Docker Compose. We have also seen how do we use network, but there is one thing which is remaining, which is volume. The problem is every time you just down this network, you will lose the data. See, every time you run this, you will get the same output. But what if you are running a container and you have added some new values? Now, even if you add those 2 values or multiple values, and then when you restart your container, you will lose data. We don't want that. We don't want to lose data. So we can achieve that with the help of volumes. What if you can store that data not inside the container, but also on the machine? Machine is there, right? But then, I mean, my machine, my personal machine. And every time you restart the container, even if you remove the container, data will still be there in the storage. So now to test it, that if you are storing some extra data in the container, it should be there even if you restart your container, even if you remove your containers. And to achieve that, first of all, let's see how do we add data. Of course, I can get data from the user, add it in the database to test it. But then we are not here to understand how do you send data from user to the server, right? What's important is how do we preserve data. So what I can do is I can create a method here, which is public void add student. And let me just create my own data here. So I will say this is, we'll go for the get request only. So I will say request mapping. And every time someone is saying add student, it should create a dummy data. Even one data should work. So what I will do here is I will just create a dummy data. So I will say add new student. And I want my AI tool to generate some code for me. Okay, still searching. So you can see the process is going on here. I could have typed the code by myself. Okay, so just giving some suggestions, set the name, set the marks, but it was not marks. It was, I think we are working with age, right? Set age. Sometimes I feel I should type the code by myself. It should be faster. Set name, let's go with Raj. I'm not sure if Raj is already there. So we are entering a new data and let's see if this works. We have to also save this. I will say repo.save student. Okay, so even if you make the changes, you have to make sure that you restart you rebuild it. So I will say clean package. And then you go back to your terminal. You stop this, make sure that you down it, and then you say compose up build. And that's done. Okay, let's see if that works. I will just go back here to the browser, refresh, and you can see we got 4 entry. But again, I will call a request for localhost 90/add student, enter. So it should enter a new student. Okay, so we are not printing anything. That's why you got blank screen. We can verify that by refreshing it. And you can see we got 5 data here. Okay, Again, if I refresh, it's only 5, 5, it will not change. Of course, if you run this one more time, it will add a new student, which is 6 with the same data. So in total, we got 6 now. But what happens when you restart your container? So I will just stop this and I will say this is down and now it's up. It should create a new container for us now. And if you go back and refresh, you can see we got 4. That means you lost those 2 entries. We don't want that. Imagine if you build an application for enterprise and then every time you restart your container, you're losing data. We don't want it. So we should store this on the system, because in the real world, you store data on the system. You store it permanently. Okay, to achieve that, we have to use something called volumes, which is basically a storage on the system. So what I will do is I will just use volume, but how do I configure that? So we have to go to our Docker compose and here create a new volume. So I will say volumes and you can give any name here. So what name it is suggesting me here? So it says Postgres. Okay, I will say Postgres data. Postgres as data for student, and that's it. So what we are doing is we are storing it on this particular storage here, and then we just have to configure that here. We have to mention that we are using volumes. So Postgres should know that we are using volumes. And which volume you are using? So you're using Postgres as data. This is the volume which you created. And the data which is available on the container, which is stored here, will be also stored on this storage. Okay, now after doing the configuration, let's build once again to be on safe side. And then stop the container, down, up. Okay, so basically we are going to use volumes now, right? So what I will do is I will just go back to the browser and say refresh. This is the default data I have. And I will run this 2 times. Now, when you run this 2 times, you will have two new entries, right? You got 5 and 6. Now, let's go back to our code and then restart the containers, down, up, and now let's see the magic. Okay, so go back on the browser, and when you say refresh now, you can see we don't just have the old data, we got the new data as well. So this is a new entry because the old data is preserved, and then you're running a new container. It is fetching that data. Additionally, you're loading the file as well, right? Which is data.sql. So it is creating new entries. So that's how basically you can preserve your data even after restarting your containers. And that's the beauty of Docker. Okay, by doing all those things we have done with the Docker series, and it was fun. And let me know if you have enjoyed it. Now, we are not just done with the Docker, is because when you start with cloud, when you want to deploy the application, somewhere we have to use these tools, or somewhere we have to use Docker to deploy it on the cloud. So that's it from this. See you next time.